G'day Jasmine, Mark Shaw here with the answers to your area of study 2 review questions. I have a feeling that every single one of your problems was caused by the fact that you didn't know this thing that I've written here in red. Australia's electricity supply is 240 volts. Right? I have a feeling that that was the one piece of information that you were missing from everything you gave me. And that now that you know that, you can probably already do the rest of this, but I'll take you through it anyway. So question 11 was the one about the power cord going to the heater. And question 11a, they gave you a graph and asked you to find out the resistance of the power cord, and you'd already found that because you didn't ask me about 11a, so that's the answer. You've already got that. Now 11b, it says how much voltage drop will occur in the cord when the heater is running. So how much voltage is going to be lost from there to there while the heater is running. Now if you can't figure out what to do first, figure out what to do last. Right? This is a classic way to work out a physics problem. Right? The last thing I'm going to do is this. I'm going to use V equals IR to find the voltage in the cord. Right? I can't do that yet because I haven't got the current. So the second last thing I'm going to do is find the current. So what have I got to find that with? This is all the question gave me, and it's all about the heater. So we have to start here. Right? I have to somehow use these two figures to get the current in the heater, and it's pretty easy because there's a formula for power that's got VI in it. So this is what we're doing. And once you've figured this out, by the way, you've actually got your sequence of attack for the whole question. If you start at the end and say, well, I'm going to do that last, what do I need? I'm going to do that second last, what do I still need? I'm going to do that third last. As soon as you find out something that you can actually do, you've literally given yourself your sequence. All right, so let's get into it. Oh yeah, the current in the heater. And because this is all sort of in series, right, whatever goes through the cord goes into the heater. The current that's going through the heater is the current that's going through the cord. That's why this is going to be relevant for us. All right. So power is VI. I is P divided by V. 2400 divided by 240 volts. That's the bit you didn't know. 10 amps. So 10 amps of current is going into the heater, therefore 10 amps of current must come through the cord. It's got nowhere else to come from. Right? So now we're getting across to this bit. Now we know that's 10. Right? So voltage in cord. And again, tell yourself what you're doing. Actually write these little subheadings as well. Make sure that you don't get lost in your own calculations, because some of these questions get big and they get like 4 or 5 or 6 steps, and often you can't figure out what you've just done. But it also helps the person marking it. If they can follow what you're doing, they're going to find your marks with a lot less effort. Okay, V equals IR. 10 times the resistance was 0.125. 1.25 volts. So 240 volts is Australia's electricity supply. That's what's coming out of every one of those power sockets that you've ever seen. It's going to have 240 volts here. And because the power cord has a little bit of resistance itself, it's going to lose 1.25 volts. So it's going to have 238.75 volts when it gets into the heater. And this is why the heater is not just a 240 volt heater. If you look on the back of a lot of appliances, it tells you what voltage it can use. And the places and the appliances that are for Australia typically can work on anything between 220 and 240 volts, because the manufacturers know that some of that 240 volts that's coming out of the wall is going to get lost if you put it through a power board or an extension cord or something like that. So they design the implement to work on a bit less than 240 volts if it needs to. All right, that's 11B. Let's get on to the other ones. Okay, like I said, I think the rest of these questions are going to be sorted out by the fact that you now know that 240 volts is going into everything that's being talked about here, but let's get into it. Question 41, this was about these three guys, a toaster, a dishwasher, and a kettle, and their power ratings. And there was a circuit breaker of 15 amps on the circuit that these things were working on. So that's the situation that was given to us. We're going to keep this in mind. We're going to need that in a minute. But question 41 asked you to calculate how much current the toaster draws. Well, the toaster's power is 800 watts. Right. So power is 800 watts. The voltage that goes into it is 240 volts. P equals VI. Solve that, calculate the I, okay? 800 divided by 240, and it comes to 3.33 amps. 3 1/3 amps. Yeah, easy when you know that, isn't it? 42. Same deal, we're going to use the same thing. Calculate the resistance in the kettle. Okay, kettle has 2,000 watts of power. Couple of stages for this. Again, the last thing we're going to do is use V equals IR to get the R, but we don't have the I yet, so the second last thing we're going to do is find I. Okay, I equals P on V from P equals VI. The kettle had 2,000 watts divided by 240, that comes to 8.33 amps. And from V equals from V equals IR, resistance is voltage over current. It's getting 240 volts. It's using 8.33 amps. So that's a resistance of 28 ohms. Okay, pretty straightforward. Okay, 43, excuse me. It says perform a calculation to predict whether or not the circuit breaker is going to trip the circuit when all three of the above devices are operating simultaneously. Well, when all three are operating, they're going to draw a combined current of 8.33 plus 3.33 plus whatever the dishwasher uses, right? And if that's more than 15 amps, because 15 amps was the circuit breaker, the circuit will break, all right? So what we have to do is figure out how much current's going through the dishwasher. So here's how to do 43. So current in dishwasher. Again, this is a good habit to get in. Tell yourself what you're doing, all right? And it equals P divided by V, which is 1200 on 240, that's 5 amps. All right. So the total current in the circuit is going to be 5 amps plus 3.3 amps for the toaster, plus 8.33 amps for the kettle, and that adds up to 16.66 amps. Now that's nearly answered the question, but you do have to sort of give yourself an explanation here. You have to say this is over the 15 amp limit. The circuit had a 15 amp circuit breaker, which means that the electrician who designed the house or designed that circuit said that anything more than 15 amps could cause a house fire or could cause a meltdown of some sort. So it's over the limit, therefore the circuit will break. Which means the circuit breaker will turn itself off and switch everything off before the house burns down. All right, last one, 44. The dishwasher cycle is 2.5 hours and she uses it 6 times a week. What is the annual energy used in kilowatt hours? Now this confuses a lot of people, this kilowatt hours thing, but this is how electricity is bought and sold. It's not bought and sold in joules. This is another unit of energy, a kilowatt hour. If you use a kilowatt of electricity for an hour, if you use 1,000 watts of electricity, that's 1,000 joules per second, and you do that for an hour, you've used 1 kilowatt hour. So to figure out how many kilowatt hours you use in a year, you figure out, well, how many kilowatts does the dishwasher use and for how many hours has it been used? So the dishwasher, the power of the dishwasher was 1,200 watts, which is 1.2 kilowatts. That's the easy bit. Now we're going to work out the hours. So every time it's used, it takes 2.5 hours. So it's using that for 2.5 hours every time you use it. She uses it 6 times a week. A year has 52 weeks. So that should be how many hours the dishwasher is on in a year. That comes to 780 hours. So to find out how many kilowatt hours she uses, kilowatts times hours. 1.2 times 780 is 936 kilowatt hours per year. There she blows. Let me know if you have any more questions about this, Jasmine. Otherwise, I'll assume that you're absolutely cool with this. See you later.